Welcome to FMA 0146 Basic Mathematics. In this video, we are going to discuss some of the questions related to indices, surds, and logarithm. First, we look at the question 1, that is simplify the following surd by without using the calculator. This is a bit of warming up. Okay, so what is the technique that we're going to use to simplify the numbers that without using calculator? So what we are going to look at is the perfect square. So excuse me, the number of perfect squares such as 2 power of 2 is 4, 3 power of 2 equals to 9, and then 4 power of 2 equals to 16, and so on. So why we are looking for the perfect square? Because if you have any of the perfect square, and then when we are square rooting it, then we will be getting the A itself. Okay, so for example, like surd 12, I know 12, okay, actually I know 12 actually is 3 times 4, where my 4 actually is a perfect square. So I can write my surd 3 times 4, and then I implementing the rules that is A square root of AB equals to square root A multiplied square root B. So this one is a square root 3 multiplying square root 4. So this one is 2 surd 3. And then the second one is 72. We can have a 9 times 8 is equals to 72. And we know that 9 times 4 times 2, excuse me, where my 9 is a perfect square and my 4 is the perfect square. So the surd 72 I can rewrite as a 9, 4 times 2. And then I have the 3 multiplied 2 square root of 2, which is 6 square root of 2. And then how about 1 to 5? I know that is especially anything ended by 5 is can be divided by 5. So what I trying to do, 1 to 5 divided by 5, so is 25. And then after that, we know that is a 25. 25 is a perfect square, so 25 by 5. So I have a 5 surd 5. 172, that is something that we cannot figure out, but we know that anything ended by 2 can be divided by 2. So we try 172 divided by 2. So is 86. 86 ended by 2, ended by 6 also can be divided by 2. So 43. Okay, now we know that 43 is not any common number that we know. Actually, 43 is a prime number. So surd 172 we can rewrite as a surd 4 times 43. So it's a 2 surd 43. Okay, let us look at the second number 2. Also is a simplified, but in this question they are not asking you to, actually is some sort like rationalizing the terms. We don't want the square root at the denominator, so we try to get rid of our denominator, the denominator with the surd, that is by multiplying the conjugate of the surd. Okay, so if you have A plus surd B, the conjugate is always the easiest conjugate is can be A minus surd B. So that is the thing we change it in the operator on the middle, we revert the sign. Or if it is only 1, okay, some sort like square root of B, so we just multiply another square root of B, so we already can get rid of our surd. So for the 3 over surd 5, we only have a surd 5 at the denominator. So what we're going to do, multiply surd 5, surd 5. So I'm going to have a 3 surd 5 over 5. So my denominator have no more surd. Okay, so how about the second question? Also the same, multiply surd 7 set 7. So then my answer is this one. Do you need to multiply in? No, just leave it at it is. Okay. So how about if you have more than one terms on the denominator? So as I said just now, if you have a plus a b, so the conjugate is the one we just simply change the sign in the middle of two terms. So then this is a minus. So what we're going to do, set 2, set 3 minus 1, multiplying the set 3 plus 1, set 3 plus 1. And we learned before, a minus b, a plus b, multiply a plus b is a squared minus b squared. So my a over here is a set 3, so a squared is a 3. And then b is equals to 1. 1 squared actually is 1, so it's 3 minus 1. The top is a set 2, we multiplied set 2, multiplied set 3, and then plus set 2. Okay, so that's why we have the 1, and the denominator actually is 2, or if not, you can always write as a set 2, set 3 plus 1 also is fine enough. Okay, so how about the second one? So the second one, which the operator here is a plus, so we are going to multiply with a conjugate with a negative 3. So then the numerator is 5 minus 1, and when we multiplying the conjugate must always multiply a pair, so the denominator is actually is 5 minus 9, a square minus b square, so it's 5 minus 9, and then our numerator we multiply, this one is 5, then this one actually is negative 3 set 5, and then we have a minus 5, and the last one actually is plus plus 3. So the denominator actually is minus 4, and then the top actually is 8 minus 4 set 5, and when we simplify, we'll be getting negative 2 plus set 5. Okay, and this question is not advisable to leave your answer at the top like this, because after you simplify, the thing can the answer totally looks different. Okay, now we look at E. E actually is there is no denominator, but they just ask you to simplify without using calculator. So what we're going to do is simplifying set 12 and set 27 by the method excuse me, we use it in the question number 1. So set 12, so I do it here. Set 12 actually is set 4 times 3 actually is 2 multiplied set 3, and then set 27 actually is 3 times 9, so is 3 set 3. Okay, so the total 5 multiplied set 12 actually is 2 set 3. Set 27 is 3 set 3, so all of them we have a 13 set 3. Okay, F, how about this one? Actually we have 15 actually is set 5 minus 3, then multiply set 3, or I can rewrite as a 5 set 3 multiple set 3. So this one is a pair, so I have a 3 set 5. Okay, now G, H, and I actually basically is just the one to let you know why I always use a plus b square, because to save some of your time, because we know that there is one standard formula, a plus b square. Okay, a plus b square actually is a square plus b square plus 2ab, and a minus b square actually is a square plus b square minus 2ab, and this one actually is a plus b, a minus b. So and actually is a square minus b square. This one is trying to save some of our time or to avoid some of the careless mistake. Okay, so my a actually is 2, so I have a 2 square. My b actually is set 3 square actually is 4 minus 3 equals to 1. So how about this one? My A, this is my A, this is my B. So A square is 4, B square is 3, and then my 2AB is 2, 2, 3. So finally, I have a 7 plus 4, 3. And we know that is the question H, the difference between G and H is only the sign. One is plus and one is minus. So for the minus, we're going to have a square minus b plus b square minus 2ab. So this one actually the answer is 7 minus 4 third 3. Okay, now we look at our J. J have a have a 2 thirds as a denominator. So what we're going to do is we just multiplying their conjugate. If you don't want to multiplying their conjugate, also doesn't matter. So what we do first is third 2 plus third 8. Okay, but we know that is third 2. Actually, third 8 is 2 times 4 actually is 2 third 2. So then finally I have a 3 third 2. So this one I have a 5 3 third 2 minus 1 over 4. I by any mean I cannot escape. I need to multiplying the conjugate, which is 5. I multiplying 2 as my conjugate. So this one will become 5 third 2 divided by 3 multiplying 2 and then minus 1 over 4. We can do the cross multiply. It's actually is 12. This one times 2. This one times 3. So this one times 2 is 10 third 2. This one times 3 is minus 3. So this is our answer. And then how about this one? Okay, if you see the denominator is a plus b, a minus b. So we knowing that is this one we just multiplying to cross multiplying. And the denominator, as I said, okay, sorry, third 3 plus 1, third 3 minus 2. Okay, oh sorry, this is not a plus b, a minus b, sorry. So what we can do, we just expand normally. Okay, so we have down here 3 plus third 3 minus 2 third 3 minus 2. The upper part is 2 third 3 minus 4 plus 4 third 3 plus 4. And then finally we have a top numerator as a 7 third 3 minus 4 plus 4 is 0. And we need to simplify our denominator. So 3 minus 2 is 1. And this one is minus 3. And multiply the conjugate 1 plus 3, 1 plus 3. So the denominator is 1 minus 3. And the top actually is 7 3 plus 3 multiplied 7. So by the end, we have the negative 1 over 2, 7 3 plus 21. Okay, let us see where I goes wrong. Okay, 3 minus 2, and then cross multiply 2 3 minus 2, and this is 4 3 plus 1. So I have a 2 3. Okay, I write it properly. 2 3 minus 4, and this one is 4 3 plus 1, and numerator is 2 3 plus 4 3 actually is 7 3. Minus 4 is minus 4 plus 4 is 0. And then I have a 3 denominator. I have a 3, then 3, and then minus 2 3 and minus 2. And then when I simplify, 3 minus 2 is 1. 3 minus 2 3 is this one, negative 3. And everything I multiplied with the conjugate is 1 plus 3. So this one is 1 minus 3. And numerator is this one. And then this is my final answer. Okay, now look at question 3. This one is no more involving. This is not no more involving the simple mathematics, simple numbers. Now we are involving the some variable. Okay, actually this one is basically some sort like your form 1 form 2 mathematics, but we just try to do it to recall some of them. So now you have a 6, 4 and 3. So when we want to simplify, what we do is we are separating them. 2 times 3 power of 2m, then I have a 2 power of 2, then minus m. Okay, 4 is 2 power of 2 divided by 3 power of 2m. And then we gathered everything related to 2. 2, the first one is 2m. Then the second one, because we know that is 2, 2 minus m. And then I have a 3, 2m divided by 3 2m. This one cancel. Okay, this is 2 minus 2m. Okay, so when you know that is you have a pn multiplied pn is pm plus n. So this one is 2m minus 2m actually is 2 power of 0, that is 1. Okay, and then the second question is, okay, if this one is a 2x, then we try to change everything into the 2x. So 5 multiplied 2x. Okay, 2x plus 1, we are using pm plus n equals to pn. So I have a multiplied 2 minus 2x, and from both terms, the similar term is 2x. So I have a 10 minus 1, then I have the 9 multiplying 2x. And then this one definitely is super easy. 2 times 3 is 6. H2 times H4 is H power of 6. It's not 8. Remember, Pn is Pm plus n. Okay, so this one is divide. So you can rewrite as 2h squared divided by sh. So you can simplify. So it's 1 over 4 h. Okay, or you want to write it in this index form also can. Okay, oh sorry, this is minus 1, so this is minus 3. Okay, so 9 power 5 multiplied 3 minus 5. Okay, so 9 power of 5 actually is 2, 2, 5. 3 power of 2 power of 5. And multiplying 3 negative 5. Okay, so we know that by sum is a 10 minus 5. So we have a 3 power of 5. And then this one is multiplying. So 4 past half plus 3 over 2 is 4 power of 2. Or if you want, you can change it to 2 power of 4. Okay, now without using calculator, they ask you to simplify. First thing, we look at it. All the base are the same. So we move log, then 5 power of 2 plus log, then 8 minus log 10 2, and by using log p plus log q actually is log pq, and log p minus log q equals to log p divided q. So I can simplify 5 power of 2 multiply 8 divided by 2. Okay, so and then I have my log 10 over here. Okay, so now if we calculated everything, so we have our 25 multiplied 8 divided by 2, actually this one is 100, or we just use this one. 25 times 4 actually is 100. So log 10 100 actually is log 10 10 power of 2, then actually is 2 log 10 10. This one actually is 1, so your final answer equals to 2. Okay, now without using calculator, as I said just now, we have log a equals to 1, and the logarithm, the power, we can always bring it to in front. So I have a 3, log 3, so this one is 1, so I have a 3. Okay, now this is base 25, this is 5. One way that is easier, that is what we can do is either you change it to base 25 or you can change it to base 2. Okay, so over here, what we do here is trying to change it to base 5. Okay, so you have a log 5 power of 3 divided by log 525 excuse me, log 3, and the denominator is log 5 power of 2, and this one bring in front 3, and this is 2, so you have a 3 over 2. Or the second thing, that is we don't change the base to 25, we change our 5 to 25. Okay, so how to get it? Okay, you know that is when 5 want to change to 25 is it belongs to 25, half actually is 5. So now 5 I change to 25 power of 1 over 2, and then the original here is 3, so I have a log 25 3 over 2, bring this one in front, so I have a 3 over 2. And then this one is a 16 log 4 power of 8. Okay, so either you change this one to base 4 or you change this one to base 16. Okay, so as usual, that is why we, okay, or we can change everything into base 2 also can. Okay, so now 2 is my problem. Okay, okay, so change everything to, let's say, base 2. Okay, okay, so 16 actually is 2 power of 4. Okay, so 4 is 2 power of 2, 8 is 2 power of 3. Okay, so 16 is 2 power of 4. Log 4 is log 2. Okay, when I want to change log 2, 8 base 2. Okay. Oh, so I think the easiest one is change to log 4, so we no need to do so many things. Okay, 4, if I change this 4, I don't need to do anything. 16 is 4 power of 2. So 16 actually is 4 power of 2. Logarithm 4, 8. Okay, these two, when I bring out 4 log 4, 8 power of 2. And we know that is given, that is, okay, when you have an a log a, okay, for x, actually the answer is equals to x. This is one of the properties of the logarithm. So this one is 8 power of 2, so this one is 64. Okay, so actually it's same thing like this one. We have a b log b for anything here, then that is the number 3. Okay, so question 6, given that log 2 equals to x, log 3 equals to y, log 7 equals to z, express the following expression in terms of x, y, and z. So means that they ask you to rewrite in the form of x, y, z. So log 12 actually is log 3 times 4. So I have a log 3 plus log 4. And then I log 3 is y. And then I notice log 4 doesn't have here, but I have a log 2. So I know that is 4 actually is 2 times 2. Or you can say that is 2 power of 2. Okay, so I have a log 2 power of 2. So it's 2y plus 2x. Okay. And how about log 0.3? So log 0.3 is I have log. Okay, so 0.3 can be, okay, what we going to do? Okay, so it's 3 divided by 10. Okay, so it's log 3 minus a log 10. Log 10 actually is 1, so this one is y minus 1. Okay, how about 10.5? Actually, 10.5 is 21 over 2. So I'm going to have a log 21 over 2. So I have a log 3 times 7 divided by 2. Then 3 actually is y. So this one actually we can separate it to log x plus log 7. Sorry, this is log 3 plus log 7 minus log 2. So I have my my y plus z minus x. Okay. Now, how about 6,000 log divided by 7? So my log 6,000 actually is 6 multiplied 1,000. Okay. And minus log 7. Okay. Then this one I separate again. Log 2 times 3 times 10 power of 3 minus log 7. So log 2 plus log 3 minus log 7 minus log 10 3. So okay, sorry, it's a plus. So we have a 3 plus x plus y minus z. Okay, now we have the last question of it. It's just asking you whether each of the statement is true or false. Okay, so the first one we have a log x over log x over y3, and we know that is we using the identity log a over b is log a minus log b, and then we have our log pq equals to q log p. So the y power 3 can be pushed it down to become 3 log y. For the log a minus b is it equals to log a minus log b. This is the common mistake some of the students will do, because when they are desperate, they want to separate the logarithm of a minus b. They always use the one in the right hand side, but you know that is log a minus log b actually is belongs to log a divided b. We only have one, we don't have two, so this one is wrong, and we don't have any rules for changing log a minus b or a plus b. We don't have. Okay, so okay, so this one, or if you look at this one, actually both also doesn't have. Log a minus b is not log a divided by log b. This one also wrong. Okay, so we only remember we only have log a divided by b is log a minus log b. The rest of it is don't have. Okay, then this one, as I said, one of the property bring the k in front, so I will have a k log x, and this one we don't have a log a. Actually these two are quite similar, this one also don't have. Remember, we own for the logarithm we have only the most basic, we have a log a plus b is log a plus log b. Then log a minus b is log a minus log b. We don't have others. Okay, if not, then you can try by substituting any others value inside the logarithm, then you will know that it is not valid. Okay, and we have a natural log power of k is k. They are, doesn't matter we have a base 2, base 10 or base natural, all others they are using the same rules for the logarithm, where for their power we can push it to into the in front. For this one is correct, because we have, first thing we bring our a in front, and we have another property of the logarithm is log a actually is 1. And then how about this one? Remember, this one either you can bring the negative inside, so you will have an ln 1 over x. This one is the one origin, okay, getting 1. Okay, or the other way we can do it easier, the ln When I want to write it not as a denominator, I can bring my x power up is x negative 1. And this one minus bring here, actually I have an ln negative 1. And again, a negative 1 actually is ln x. And then the last one over here, you can always change the base. Okay, if you don't want to change the x with the smaller base, so ln square root of x, x actually is third x power of 2. And then originally have a 2k there, and then these two are the same, push this one in front. So this video ended here. Thank you. If you need more exercise, you can look at your module. Thank you.